and the dependent variable is the y value. Now, kids make a big mistake here all the time. When I write 1, 3, that's an x and a y, right? And it's also an IV and a DV, right? And it's also a domain value and a range value. Everybody understands that, yes? Now, if I then write just the domain, these values are no longer considered an X. They're just elements of that set, okay? Which seems like it's not important. But when I list a range, this is now elements in the set of the range. We always write them least to greatest. Now, you will notice that 1, 2, 3, 4, my domain values are already listed least to greatest, yes? And the ordered pair, the XY, is also listed least to greatest, yes? So when I list them as a domain and as a range, they line up. And I was talking about this when the bell rang yesterday. But I didn't drive that car today. I was trying to find Wimmer this morning to tell him that, but I didn't drive it today. And I probably won't have it tomorrow. So I'm not worried about it. I mean, he can look at it Friday if he wants. Okay? Actually, you know what? Ethan, I will have it tomorrow. So tell him I'll have it tomorrow. When I list this, this happens in this case to work out that these are still the ordered pairs. But they aren't always going to be. Does everybody understand what I'm saying? You'll see it on this very next one. Okay? So, what are the ordered pairs here? There's 1, 0, 0, 1, -1, 0. I ran out of room, son of a brother. 1, 0, 0, 1, -1, 0, and 0, -1. Ordered pairs, yes? Okay. What is the range or domain value, which I've been writing in green? Where do I find the domains?
On the left.
They're the X's. Now, you see there are 4 numbers there, yes? Do I write 4 numbers? No, because I'm only writing elements of the set. So what's the lowest number there?
0.
No. -1. And then what's next? 0. And then what's next? 1. And I use those squiggly brackets. So even though there's 4, there's only 3 elements in the set. Does everybody understand? Okay. And the range values I've been writing in blue. What are the range values? What's the lowest range value you see there? -1, 0, 1. Correct? Now, notice, when I write them as domain and range, is this a pair anymore? Is there -1, -1 somewhere in the pairs? No. So you have to be careful for that. Don't assume that these are going to pair up. Is everybody cool? All right. Now, let's see if it's a function. If it's a function, every input will give me a unique output, yes? So when I input -1, what outputs are there? So I check here. -1's output is 0. So there. Is that unique? We're cool, right? As of now, it's a function. Everybody agree? Okay, what if I input 0? 0 goes to 1. So we're okay there. But it also goes to -1. Is that okay? No. A relation works because if I say 0, you can say, if I were to graph this, 0, -1, or +1 and -1, right? Those are those points. If I say to you, I'm thinking of a y value that exists at x, or I'm thinking of an x value that exists where y is 1. So you would go to where y is 1 and you would see, oh, 0, it's cool. I'm thinking of an x value where y is -1. Oh, it's 0, it's cool, right? But if I reverse it and I say I'm thinking of a particular y value right now where x equals 0, do you know which dot I'm thinking of?
No.
So it's not a function. It's just a relation. Everybody cool? Not a function. Okay, so now you try this one. Set up the domain and range, list them, tell me if it's a function or not. Go. Would anyone like to volunteer? How many values need to be in the domain list? 4. What are they?
2, 4, 6, 8.
Who do we appreciate? Math, rah, rah, rah. Everybody good? Okay, now, what are the range values? 3, 5, 7, 9. Now, does this one happen to line up? Is this one of the pairs? Yeah, it is. It's cool. Is this a function? It is, isn't it? Because 2 only gets me 3. 4 only gets me 5. So this is a function. Can everybody do this with points? Does everybody see how it works? If an x hits 2 y's, or an input hits 2 outputs, or a domain value hits 2 range values, it's not a function. Everybody good? All right, now you're intelligent young people. All of these points exist on a graph, don't they? So if you look at the next question, I have a graph. Now, isn't this exactly the same as this? This is data. This is a representation of that data, right? So, what are the domain values? Where do I find domain values?
X-axis.
On the x-axis. So I only need to look on here, right? So let's do that. What's the least x value I have? -3, because it's right there, yes? What's the next one? -2. What's the next one? 0. What's the next one?
1.
Then 3. Everybody agree? All I did was check the x values. Yes? Everywhere there's a dot, I took the x. Yeah? Okay, how do I do range? I check the y values. Where's the lowest y value? Top or bottom? Bottom. So what is it? -3. Then what? Then what? Then what?
0.
Then what?
1.
Then what? 2. Everybody cool? Now, are any of these pairs? No. Well, maybe, but not automatically, right? Now let's check if it's a function. Is it a function? Let's check. We have to check our x values, yes? Well, there's my first x value. How many outputs does it have? 1. Is it a function right now? Yes. There's an x value. How many outputs does it have? 2. Is it a function? No. Because when I say I am at -2 on the x-axis, which of these dots am I thinking of? Can you tell me? No. Because whatever you say, I'm just going to say I'm thinking of the other one, right? Everybody understand? Everybody cool? So, let's remember. Functions have 1 range value for each domain value. Now, some of you aren't going to remember domain and range. You're going to remember it this way, and that's okay. They have one y value for each x value. Okay? Everybody cool? All right. Now, keep this drawing in your head. Has everybody got this? Everyone sees it, right? Remember the two red dots that I made. There and there at x equals -2. We're cool? Okay. Turn the page over. The vertical line test. This only works on graphs. So you have to have a graph. All right, so let's make a graph. On the far left of this box, let's make a graph. Everybody cool? We just make the x and y axis, yeah? Okay, now just draw a straight line diagonally anywhere on the graph. Everybody draw one. Doesn't matter where you put it. I'm not drawing one because I don't want you to copy me. I want everybody to draw their own line. Is everybody drawing a line? Okay, I'm going to draw mine. And this is where somebody says, I drew that one too. Nobody? Sweet. Okay. Now, each dot on this red line, like for example right there, has an x and a y value, doesn't it? And so does this dot, and so does this dot, and so does this dot. Is everybody cool with that? Now watch. Pretend that's perfectly straight. At that x value right there, how many y values are there? 1. Everybody cool? As I slide that line along, how many times does my light blue line hit the red line?
As many times as there are points.
That was a bad way to read that question, obviously. How many intersections are there between the blue line and the red line? 5. 1, right? The blue line only hits the red line at any given point once. Everybody cool? So this is a function. Now, over here, let's draw another graph. And this time, we're going to draw a curve. We're going to draw this. Everybody cool? Is this a graph? Yeah. So let's do our vertical line test. How many times does the light blue line... Oh, I'm bringing the x and y with me. I didn't mean to do that. Sorry. How many times does the light blue line hit the dark blue line? Oh, now I'm bringing the WO from Works. Screw it. How many times does the light blue... Shut up! It's not easy. Only people that have actually tried to use the magic pen are allowed to laugh right now. How many times does the light blue line hit the dark blue line? Once at any given time, yes? So is that a function? Yes. Because for every x value, there's only one y value. Now let's draw a third graph. And this one, we're going to make pink. Is that a function? Son of a motherless. Is it a function? Yes, 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 yes. Oh! What happens at that x value? There is 1, 2, 3 y values. So is it a function? No. This is a relation. So what is the vertical line test? A vertical line will only hit single points. On the graph. Keegan. No. Let me show you. Let's choose a light green. So right there, you're going to say it hits 2, yes? But my input is negative x, and my output is positive x, right? Those are two different inputs. So if I say I'm thinking of the y value that goes with negative x, there's only one of them, right? So it's a function. Okay? Everybody cool? All right. So let's look at this next question. Is this a graph? Yes. So can we apply the vertical line test? Let's try, shall we? Now, it's a little hard to see, so I'm going to make each dot a little bit bigger. And already you should be able to see whether it's a function or not. That purple dot's going to come with me, but it was there. Is it a function right now? Yeah, 'cause it's only hitting that purple dot. What about now? Yep, because don't forget that bottom one isn't part of it. I'm going to get rid of it because it's a pain. Oh my God. You're such a piece of crap. Such a piece of garbage. I don't want purple. All right. Once. Oh, what happened there? 2. So at the x value of 1, I have 2 outputs, don't I? And then that happens again over here, doesn't it? So this is a relation. But am I still able to list the domain and range? Do I have input and output values? Okay. The domain values live on what axis? The x-axis. What's the first number I write? The biggest or the smallest? Smallest. Where is the smallest x values? Left or right? Left. So I go all the way to the left, and what do I find? -3. What's next? What's next? -1. What's next? Then. And I list them all. Why do I list them all? Because do you see any x values between -3 and -2? No, there's nothing on the graph, right? Everybody cool? Okay, now you do the range. What are the range values? Don't say it out loud, just write it out. Remember, we put the lowest one first. Where do we find the lowest range values? The top of the graph or the bottom? Bottom. So what's the lowest range value you see? And then we go on. -1, 0, 1, 2, 3. Please notice we have less range values than we do domain values. Is that okay? Yes, because we're only listing the elements of the set. Everybody cool? All right. So let's look at the next one. Is this a graph?
Can I see the top?
Is the next thing down a graph?
Yeah.
So can we apply the vertical line test to it? So let's do so. There's my vertical line. How many times does it hit the dark blue line? Once. So is it a function?
Yes.
Excellent. So we have a function. Good. Now, let's talk about the domain and range because it's different. All right? It starts the same. What is the domain? It starts at the lowest x value. What is it? -3, right? 1, 2, 3. Everybody cool? Is everybody cool? Now, this is different. Is there an x value at negative 2.9999999? Is there an x value at 2.9999998? 7, 6, 5, 4, 3, 2, 1. Is there an x value all the way along here?
Yes.
No matter where I go, I get an output, don't I? How many numbers live between -3 and +3? Infinite, because of all the fractions, right? Could we write it this way? -2.9999999, comma, -2.9999998, comma. Would we write that? No. So this is where we do that other thing that I've already shown you once. -3 is the lowest value, right? So -3 is less than x. Does everybody agree? Because all my x's have to stop at -3. Cool? Now, but x could be bigger than, what's the biggest value I get to? +3. Now, look closely. Something weird happens here. See how this dot is colored in? Most of you should have seen in grade 9 this move. X is greater than 9. Draw the graph. There's 9. Put an open circle and draw an arrow that way. Most of you should have seen that in grade 9. If you didn't, I'm not going to teach you. It's no big deal. This open circle means 9 does not work. Is 9 greater than 9? No, 9 is equal to 9. If we color it in, that means 9 is included, and we put an equal sign here. Are these two dots colored in?
Yes.
So are they included? So I need an equal sign. Is everybody good? All right. So that's the domain. When we write it this way, it means every single number between -3 and +3, including all the infinity of decimals. Everybody good? And you all see the difference here, right? Because there is no output for all that infinity of decimals between -3 and -2. So I cannot do this. Now that you know how to write it, how do you think you do the range? Where do we look for range values? On the y-axis. What's the lowest one? -2. Is the dot at -2 colored in?
Yes.
So do we need that equal sign? Yes. Are we counting x's or y's here? Y's. And how far up does that line go? To +3. Is that dot colored in? So do I need the equal sign? It's colored in. 3. Is everybody cool? That's the most basic way to write domain and ranges. Now, sometimes you'll see this will be added. X is a set of real numbers. I showed you that earlier, right? None of that really matters, right? This is what's important. This is called set notation. Please highlight that. That's one way we write it. There's another way we write it that is shorter than this. But it follows the same rules. The domain is still -3. Domain is still -3, and it goes up to +3. And we put a comma. Now that looks like an ordered pair, doesn't it? So you got to be careful here. I'm only thinking of domain. Is this -3 included? Yes. So we put a square bracket. Now there are some kids that call this a hard bracket. Whatever you call it, I don't care. Is this 3 included? So we put a hard bracket. Everybody cool? So what would the range be in this type of notation? Hard or soft bracket? Or hard or a rounded bracket? Hard bracket, square bracket, and what would the first number be? -2, comma, up to what? 3. And what kind of bracket? Hard bracket, square bracket, because it's equal. This is called interval notation. This one only works for lines. Okay? Because we couldn't do interval notation on the dots, could we? Because there's no parts of the x-axis that are colored in. Everybody good? All right, knowing what you know, let's have a look at this one. Now, this is a weird graph. Is it a graph? Yes, so can we apply the vertical line test? Yes. So there's my red line. How many times does the red line hit the graph? Once. Are we okay? Then it doesn't hit it at all, but then once. Is this a function? Yes. But this is a weird function, isn't it? Because there's 2 lines on the graph, yes? Do you think anything changes in how we calculate the domain and range now? Do you think? Where does domain live, Keegan? On the x-axis. What's the first number I write? The lowest x value, which is what? Look again. -30. Why? Because the scale has changed, right, Jazz? So, is -30 colored in? So do we include it? So -30 less than or equal to x, right? If in set notation, what would it be in interval notation? Hard or soft bracket? Hard bracket, -30, comma. Everybody good? All right, so here I am at -30, and now I start trucking along. When do I stop?
Right before the -10.
I stop at -10, right? -10.0000000000001, right? But I don't get to 10. So will x ever equal 10? No. So no equal sign there, so I put a 10. And then I put my squiggly brackets around it. What will I put here? Sorry, -10. What will I put here?
A round bracket.
-10 and a round bracket. Is everybody good? Now, if none of this were here, would we be done? We'd be done the domain, wouldn't we? Right? Because that's the only x values we have. But all of this is here, isn't it? So the domain starts again right there. What's that value? 0. Is it colored in? So I have to equal x, don't I? And how far up does it go? What's that? +30. Is it colored in? No. So I'm going to be less than 30. No equal sign because it's not colored in. Right? Then I put my squiggly brackets. What would it look like in an interval notation? What's my first bracket going to be?
Hard.
And what number?
0.
Comma?
30. Soft.
30 soft. Now, because there are two sets of domains here, we put a big U in the middle of it to stand for union. Everybody cool? Everybody cool? All right, now you try it for range. My range, and I want it in set notation and in interval notation. Go. Talk to your neighbor if you need to. It's tricky, but I have the utmost faith in all of you. Where do I look? Which axis? The y-axis. At the top or the bottom? Bottom. What is that value? Negative 20. Is it colored in? So is it included? So negative 20 less than or equal to what goes here? Y. And what does that go up to? What's that y value? 0. Is it included? No, because that dot is not colored in. So I put just a less than sign 0 and my squiggly bracket. How do I do that in the other notation? Hard bracket negative 20 because it's equaling negative 20 up to what?
0.
With a soft bracket. Everybody cool? Pardon? Because this 0 value, this point, is not colored in. So the point negative 10, 0 doesn't actually exist on the graph. Negative 10.001, comma, negative 0.001 does exist. You with me? Okay. Now, does the range start up again? Right there. What's that value? 10. Is 10 included? How do you know 10 is not included? That is not colored in. So do I need the equal sign here? No. Then a y up to what? 30. Is the 30 included? How do you know? Colored in. So I need the equal sign. Squiggly bracket. Yes? Paige, are you typing everything I say? No. To text to a friend?
I'm just texting my mom back. She's worried.
Finish. I don't care who you're texting. Finish quickly before I take your phone away. Because I get very tired of answering questions that I've answered in the notes because kids are not paying attention. Thank you. What value goes first here? 10. What kind of bracket? Soft. Then 30 and hard. U and U. Everybody cool? All right. Let's look at D. Is it a graph? So can we run the vertical line test?
Yes.
Let's do it. Is it a function? Yes, 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 yes. How many people say it's not a function right now?
Wait, can you move it again? Oh, it's still a function.
It's still a function. Why?
Because there's the hollow circle and then the solid circle.
That dot doesn't exist. Everybody understand? Everybody with me? This is a very special function called a step function. And believe it or not, this is how people used to get billed on their phones. If you used it a certain amount, you paid a certain amount. If you used it more, you paid a little bit more. If you used it more, you paid it a little bit more. That's how phones used to work. Text used to be 10 cents per text. People don't believe me. You kids don't believe me that that's what it was like, but that's what it was like. You had to really decide if you wanted to talk to someone, because it cost you 10 cents every time you did. And if you accidentally sent a text, like a butt text, LMQJJ7XY, and send got hit, cost you 10 cents every time. You'd be surprised how quickly it burns up. I have an American phone because I visit America every so often. I pay 10. I get 30 free texts, and then it's 10 cents a text. So at the beginning, every time I go down there, I treat it like my Canadian phone. I'm texting people, hey, how's it going? Oh, it's okay. You want to meet here? Sure. What time? 8 o'clock? 8 o'clock doesn't work for me. How about 7 o'clock? Doesn't work for me. And I use up all 30 texts. And then after that, it's like, meet here at 8. Don't return call. Because it starts costing me 10 cents a text. And nobody's cheaper than teachers. Because let's remember, 10 cents in America, it's like $87 here. All right, so we all cool? We know it's a function? So you're intelligent young people. What is the domain? In both forms. Go. This is tricky. Kids, screw this one up. Think about it. When you think you have it, pull on your left ear. I'm sad to report not much ear pulling. Better. It's improving. Left ear. Left ear. It's improving. Seeing a few left ears being pulled. What's funny is when I watch people pull the wrong ear and then realize, oh, darn it, I've pulled my right ear, but I'm supposed to pull my left ear. I worry because all of you are, of course, about to get driver's licenses. Turn left. Oh, no, left! Ah! I'm not at all worried. I know you all will be stellar drivers. Just out of curiosity, how many of you are planning on getting your driver's license? Because a lot of young folk actually don't. Yeah? Okay. Okay. What is my lowest value, ear pullers? -6. Do I hit -6? No, so it's a regular arrow. There's no equals. Then an X. What's my highest value? No. Because what happens right away at -3? It jumps up and starts again. Right? So, since yes, you're right, open circle, and then it goes to there, but then it starts again right away because we only care about X values. So I go all the way along to what? +6. Do I hit +6? Yes. In interval notation, soft, hard bracket. Right? Now, this is tricky. What is the range? Where do I find range? Only on the y-axis. You know how to write this. You've seen enough. It's tricky. This question has everything we've done so far in it. Big hint. Everything we've done so far in it. All the way back to this question. When you think you have it, take your left hand and wave. Just wave with your left hand. Ryan waved with both hands, just covering it up, covering both sides there, Ryan. Guravir covering both sides, just not quite sure which is left and right. All right, what's the range?
Soft bracket, -3.
You cannot put a soft bracket. Soft brackets only work when there is a line. 3, 6, 9. Only. Because we only care about y values. All of these x values are 3. All of these x values give me a y value of 6. And all of these give me a y value of 9. If this happened somewhere, you would fill in this, right? But it doesn't. It's single dots. If you have dots when you are finding your domain and range, you cannot use these or these. Which is why for x, we were able to use them because you can see I colored all the way in. Everybody cool? Everybody good? Okay, now there's only one other thing we have to talk about, and that's why we have this much blank space here. Draw a big graph.
Okay.
Everybody good? Everybody good? You don't need a ruler. 1, 1. Everybody cool? 2, 3. Draw a curve that goes anywhere from the left up, hits the 3, and then goes down. Oops. And put arrows on the end. What do the arrows mean? It keeps going. For how long, Sukhdev? Ever. Right? So, is this end of the arrow slightly going left? So how far left will it go? Infinity. What do we call the left side of 0? Negative. So my domain here would start at negative infinity, wouldn't it? Everybody with me? Will it ever get to negative infinity? Will it ever equal infinity? No. So we got to put that kind of arrow, right? Then an x. Is this one going ever so slightly right? So what will it get up to? Will it ever hit positive infinity? No. Positive infinity. How do I write that as an interval? Soft bracket, negative infinity, positive infinity, soft bracket. Is everybody good? Everybody's good? Yeah? Okay. What is the range for this curve? What is the lowest y value I'm going to hit? What do these arrows mean? It's going down for how long? Infinity. So my lowest number here is negative infinity, isn't it? Will I ever hit it? No. Why? What do I go up to? 3. Do I hit 3? Yes. I go right through it, so I equal 3. How do I write that in the other form? Soft, negative infinity, comma, 3, hard bracket. Is everybody good? Everyone's good? Now, if I changed this curve to end right there, what will change? The domain, the range, or both? Guravir says domain only. Keegan says both.
I think both, yeah.
Nino says both. Let's check. Does this arrow still go downwards? So am I still going to hit negative infinity going downwards? Am I still going up to 3? So does my range change? No, because if I took I would still go from 3 and I'd have to color all the way down to what? So that didn't change. Now, when I'm doing domain, I would have to color this whole graph the first time, right? But now it ends there. So I would only color this. So what would my range become? Do I go up to infinity anymore? What am I going up to? 2. Am I hitting 2? So it would be the equal sign. And this would become 2 with what kind of bracket? A hard bracket. Is everybody good? All right, now listen to me carefully. On page 82, there's a few easy questions. All right? Do not do. All I want you to do is 5 and 8 right now on this page. Please write that down. Just 5 and 8. Then go to the next page. On the next page, you can do as much of that as you see fit. Okay? If you do a few and you're getting all the right answers, you could probably stop. Everybody good? All. Yeah? All right. That's your job right now. Right meow. Okay? Yo. Yes. Everybody cool? Class ends today at like 10:49 or something. So you got 20 minutes to do those 2 pages. That's a lot of time. All right? Nina. Yes. Yo. Sure. I think you can. You're right, Aaron, you didn't. Ahmad, you're still in the running for the prize. Hina's still in the running for the prize. Mariah's still in the running for the prize. Gavin, is that you? Gavin's not here. That's Gavin, right? He's still in the running. Gervier's still in the running. Gerner, oh, no. Arwen's still in the running. Holy crap, I'm going to have to buy a lot of prizes. Sukdev, Ria, Jocelyn, Wayne, Jamie, Ezra, man alive. Oh, she's not in the class anymore. Phew, saves me 1 prize. Dan's still in the running. Edward's still in the running. Jazz still in the running. Now, Carlo, you miss a lot of class, so I don't know. Maybe I should make this attendance as well. Pace. Is Pace in? Oh, is Pace in? Oh, Pace, no. Ryan's still in. Man, that's a lot of prizes. Tony. Antonio. He's got like 87 names. I don't understand. When I was a kid, you got 1 name. And it was your name. Right? Like, I've been Matthew Myers for almost 45 years. Nothing's changed. But I have documents that have some of you with like 87 different names on it. Nino, for example, is In Check My Progress, he is Avelino Diaz. In attendance, he's Nino Hernandez. I don't understand what you people do with your names. It's just a name. I know a lot of people make a big deal out of it, but I just don't.